All right, here we go, section 11.5, volumes of prisms and cylinders. Okay, so today our objective is to find the volumes of prisms and cylinders. Use the formula for density. Use the formula for density there. And then use volumes of prisms. Use the volumes of prisms and cylinders to solve problems. Okay. So first, let's go ahead and let's start with what is volume. Volume is a measurement used for solids. So volume in a solid. Volume is the number of cubic. Again, we're thinking of a cube there. Cubic units, okay, contained in the interior. Okay, so here we have a couple different solids. So here we're looking at, so for this right prism right here, this is a triangular prism. If you see there, the base is a triangle. We're looking for the number of cubes, little cubes like this guy right here. How many of those cubes would fit inside this figure? Okay, we're going to talk a little bit of math history here. Cavalieri's principle, okay, is named after a Bonaventura Cavalieri, lived in the late 15th, early 16th century. And he stated that two solids, if they have the same height, meaning if their total height, top to bottom, that height there, and again, this same height, top to bottom, so the very top to the very bottom, if they have the same height and the same cross-sectional area, meaning the area of each cross-section, meaning if I was to cut through the figure at the bottom, if the area of that bottom is the same as the area of that bottom, and every cross-section narrow out, meaning if I slice through the middle here, you see here, this would have a triangle sliced through the middle, and so would this one. If the area of each of those levels, the level all the way up, each of those levels is the same, then the two figures have the same volume. So if I have two solid figures, so if I have two solids with the same height, okay, so two solids, and if they have these two things, if they have the same height and the same cross-section area at every level, okay, so this is, we'll do it in an if. If two solids have the same height and the same cross-section area at every level, then they have the same volume. And what Cavalieri noticed then was then if I have here an oblique prism, see an oblique doesn't go straight up. Most of the prisms you dealt with up to this point have been right, meaning the top, the two bases are directly across from each other, okay? Here, an oblique prism, they're not. They don't make those right 90-degree angles. Because if you notice here in a right prism, the lateral sides there, those lateral edges make 90-degree angles. In oblique, they do not, okay? What he noticed then is as long as then this base area is the same, as long as this base area, this area down here, is the same as this one, and they have those same heights, then really their volumes are going to be the same. So then we don't need different equations for volumes, okay? So how do we find the volume? Okay, the volume of a prism is equal to big B, where B is the area of the base, and H is that height. And again, it's that perpendicular height. So that perpendicular height, okay, that 90-degree angle height. B, again, big B. And again, I've been stressing all year about using the correct uppercase, lowercase. So here an uppercase B has a very different meaning than a lowercase b, okay? For example, we had area equals base times height. I always used a lowercase b because that represents the length of the base, length of base. Where how in this, the uppercase B, that's actually the area of that base. So it's important you know how to find area to be able to find the volume of a prism. So basically what I do is I figure out what's the base of this prism. What is that base? Let's do it in red. What is this base? Find the area of that guy. Then multiply it by the height of the prism, this guy right there. Okay. All right. Let's go ahead and let's do some examples. So here, find the volume of each prism. Okay, so here for A, first thing you have to decide, what is this guy? Okay, well, if we notice here, okay, this is a rectangle, this back is a rectangle, this back is a rectangle, but this right here is a triangle, and this is a triangle. So I know this is a triangular prism. So to find the volume, I need the area, big B, times height. So now let's go ahead and let's find the area of that base. So let's find the base. The base is this guy right here. They help us by telling us that it's a right triangle. So I'm just going to draw the base. Here's what the base looks like. We have a right angle here, and that's the same as this one here, because it's a nice right prism. So then I know this side here, this side is 3, so then this side here is 3. So we know this guy right here is 3. So since this one is 4, this one here is 4. So I know that is 4. So here the volume then would be the area of this base. So I need to find the area of this right triangle. So my big B is going to be equal to the area of that right triangle. So it's a good thing we know how to find area. The area of that right triangle is 1/2 base times height. 1/2 3 times 4. So that's my big B, or my area. So my big B, the area of my base, then is 1/2 times 12 is 6. So the area of my base is 6 times the height of the prism. So the height of that prism is this height right there. So the height of that prism is 2 times 2. 6 times 2 is 12. So it'd be 12. My units are centimeters, and its volume, so it'd be centimeters cubed. So the volume of that figure is 12 cubic centimeters. Okay. Next one here, okay, so part B, if you notice here, here's a rectangle, and then here's a rectangle, and then we have one here, and then one here. So our base would be this guy down here at the bottom, okay, so this guy right here, which is the same as this guy up here, which is a trapezoid. So let's go ahead, and I'm just going to draw that trapezoid off to the side. Ish. There's my trapezoid. Okay, so we know this long side here, there is 14. So this long side is 14. We know this little piece, they give it down here, is 6. So I know this piece is 6. Okay, and then I know this little distance, that would be that height. This distance right here is 3. Okay, so there's my trapezoid. Let's fix this side a little bit. There's my trapezoid. Okay, so to find the volume, big B times 8, this is a trapezoidal prism. So I need to find the area of that base first. The area of that base, if you don't remember how to find the area of the base of a trapezoid, it's 1/2 the height times the sum of the bases, base 1 plus base 2. I'm kind of squished there. Okay, so my area is going to equal 1/2 times my height, which is 3, times add the bases, 6 plus 14. Okay, 1/2 times 3, 6 plus 14 is 20. 3 times 20 is 60. Take half of that. I get 30. So that is my big B, the area of my base. So the area of my base is 30 times the height of the prism. So the height of the prism right there is 5. It's 5 units high. 30 times 5, 150. My units here again are centimeters, so it would be cubic. Centimeters cubed. Okay. All right, next, the volume of a cylinder. Okay, cylinder has the exact same concept of a prism. Again, we have the two bases, but my bases here are circles. So a cylinder is basically a prism. It's not a prism because it's not a polyhedron. Okay, but it just has bases that are circles. So if you notice here, the equation is the same. Volume equals big B times H. I always use that one. You could memorize. You know that the base here is a circle, and we know the area of a circle is pi r squared. So what they've done is they replaced the big B in this equation. So replace that big B right there with the pi r squared. Okay, with the pi r squared. So they replace this big B, they replace this big B with pi r squared, because we know the area of the base, and they got this formula here. But I like to remember the least number of formulas possible, so I still go with volume of a cylinder or a prism, big B times h. Area of the base times the height, regardless of whether it's a right cylinder like this or an oblique. So this guy right here is a right cylinder, again, because it makes that nice 90-degree angle here with the ground. And this one here is what we call an oblique. Again, not right. Oh, that should be a Q, not a G. Oblique cylinder. Okay, right, so let's find some. Find the volume of each cylinder. So, volume of the cylinder, big B times H. So my base here, here's my base. It's got a radius there of 9, because this is 9 also. So my big B, my area of that circle, is pi r squared. So pi times 9 squared. 9 squared is 81, so 81 pi. So my big B here is 81 pi, that's the area of my base, times the height of my prism. The height of the prism there is 6 times 6. 81 pi times 6, so I'm going to take, get the calculator out. 81 times the 6 is 486 pi, and that would be feet cubed. Okay, if we want to do approximately, 486 times pi would be 1,526.8 cubic feet. There's exact, and there's approximate. Okay, all right, so now this next one, again, volume equals big B times H. So to find that big B, my base is a circle, so pi r squared. Pi times my radius there is 4. See, the radius of that is 4. So the radius of that is 4 times 4 squared, so that would be 16 pi. Okay, so that's my big B. And then I need to multiply it times my height. The height is not how long this is. We're not looking for how long that is. We're looking for that straight up and down perpendicular height, which in this case is the 7. So the 16 times the 7 is 112 pi. And that would be centimeters cubed, which is approximately 112 times pi, 351.9, and again, centimeters cubed. There's exact and approximate right there. Okay. All right, next, density. What is density? Density, if you remember from science, is the amount of matter. Okay, so it's the amount of matter, okay, that an object has, amount of matter in a given unit of volume. Okay, really how many cells or how many atoms or whatever are in each unit of volume. Okay, for example, water is more dense than air. Okay, because air, the molecules are farther apart, whereas water, they're closer together, whereas a solid is going to be even more dense than, let's say, water, okay, depending on the solid. Okay, so really density, our equation for density, figuring out how dense an object is the mass of an object divided by its volume. Okay, so for density, we take mass and divide it by volume. Okay, different materials have different densities. The one density that's known most often is the density of water. Most farmers and ranchers know the density of water. Little bit of a question there. That's a really good question after you watch the video. Ask mom, dad, brother, and sister if they know the density of water, or more so like how much does a gallon of water weigh as far as weight. And again, that's kind of one of those bits of information that most farmers, ranchers know. I'm sure you can probably think of why they would need to know that. Okay, So let's go ahead and let's do an example involving density. So the diagram shows the dimensions of a standard gold bar at Fort Knox. Okay, Fort Knox is one of the places in the U.S. where the U.S. Mint holds its gold reserves. Gold has a density of 9.3 grams per cubic centimeter. So every cubic centimeter of gold weighs 19.3 grams. Find the mass of the standard gold bar to the nearest gram. So we want to find the mass of that bar. Again, that mass in grams. So our equation, density equals mass divided by volume. We know the density. This is the density right here, the density of 19.3 grams per cubic centimeter. So we know this guy. We know this density right there. We know that's 19.3. We're trying to find the mass. Ooh, let's do that. We're trying to find that mass. So I'm going to have to find the volume. So I need to find the volume of this guy. So again, volume is a rectangular prism, big B times H. So I need to find the area of the base. If you notice, my base would be this rectangle down there, which is 7, not a very great picture, okay, which is 7 inches on one side and 3.625 on the other. So my big B, and so to find the area of a rectangle, it's length times width. So 7 times 3.625. So calculator, 7 times 3.625. We get 25.375 times the height of that prism. So the height there is 1.75 times 1.75. So 44.004, I calculated 44.40625. Okay, didn't round, that's exactly what it is, 44.40625. So that's my volume, is that right there. So my density, again, I know the density is 19.3. Equals the mass, which we're trying to find. So I'm just going to use M divided by the volume, which is 44.40625. So to solve for mass, I'm going to need to multiply both sides by the 44.40625 times 44.40625. Those cancel, so my mass is equal to times 19.3, 857 point, let's go 0.4, and my mass, the density is in grams per cubic centimeters, grams per centimeter cubed. This unit is in centimeters cubed, so that mass would be then in grams. 857.04 grams. Okay. Okay, one last one. You are building a rectangular test. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? So we're trying to figure out what the height of this should be. So let's do our equation. Volume equals big B times H. We know the volume is 72 cubic feet. So I know V is 72. Big B is the area of the base. I know the base of this guy. It's a rectangle. That's 6 by 4. So the area of that base would be length times width. So length times width, 6 times 4. So my base is 24. The area of my base is 24 times my height. I don't know the height. So now we'd have to divide both sides by the 24. 72 divided by 24. My height would have to be 3. My units are all in feet, so my height would have to be 3 feet if I want this chest to have a volume of 72 cubic feet. Okay. Similar solids. Two solids. If two solids are similar, okay, if two solids are similar, okay, then the ratio, okay, of their scale factor, okay, so let's say their scale factor K, the ratio of their volumes would be, okay, similar solids. So if I have two similar solids, similar solids with a scale factor K. So if I have similar solids with a scale factor of k, then the ratio of their volumes is k cubed. Because again, their volumes is unit cubed. So if the scale factor from one to the other is k, then their volumes have a scale factor of k cubed. So I can use that to actually help me find the volume of similar solids. For example, here, example 6. It says cylinder A and cylinder B are similar. So I know they have a fifth scale factor. So let's find just their plain old scale factor. Their scale factor. I'm going to go big to small. So big over small. They show me the radius there. The radius of this one is 6. This one is 3. So the scale factor of their linear measurements would be 6 to 3, which is 2, or 2 to 1. So that's our scale factor, k. So then the scale factor of their volumes, their volume scale factor from one to the other would have to be k cubed, which is 2 over 1 cubed, which 2 cubed is 8, so 8 over 1. So the ratio, this is the ratio of their volumes. The ratio of their volumes has to be 8 to 1 if I go big to small. So if I'm looking for the volume of the big one, I'm looking for the volume of this big one, the ratio of their volumes has to be in this 8 to 1. So the ratio of their volumes has to be 8 to 1. So 8 to 1 has to equal the ratio of their volumes. We're trying to find the volume of the big one, but I know the volume of the small one's 45. So there I have my equation. 8 over 1 equals V over 45. Now if we cross multiply, take the 8 times the 45, 360, the 1, and then take the 1 times the V. So 360 would equal 1 times V. Well, there we found it. The volume of the big one would have to be 360 cubic centimeters. Okay. And if you remember from a previous section, we're talking about area. The scale factor of their areas is that scale factor squared. So the scale factor of their volumes would make sense that it would be k cubed. Okay. All right. I think that is it. Good luck.